Hello everyone. Can someone just confirm that you can hear me and that you can see the slides?
Yes, everything is fine.
Okay, thank you very much. So let me just reintroduce myself in case someone didn't wasn't here yesterday. My name is Andrei Boris. I'm a doctoral student at University of Rijeka, and this is data storage and management class. Yesterday we covered three initial topics focusing on the basics of data storage, including how data is stored in the computers and media that is used to store it. Today we are going to move on to some advanced topics such as data redundancy, how data can be transferred, and and some advanced data storage methods. We will probably cover databases today, and then leave structured data for the final lecture. Okay, so let me start here with data redundancy, our fourth topic. So essentially, I mentioned that in the last lecture of Monday, I mentioned backups and certain techniques like that can be integrated directly into file systems. Uh, this sometimes isn't enough for us. We want to achieve a higher level data redundancy. What does data redundancy means? It essentially means that data is stored in at least one more copy somewhere to protect against loss. So the simplest way to achieve this is obviously we can have a backup somewhere if you are taking maybe an important document that you have and storing it onto hard drive, external hard drive. That's data redundancy. One of the biggest issues with this is that this isn't always enough. Just picking up data isn't always something that's satisfactory because well, people forget to do backups. People, even if you trigger it to do it automatically, will forget to plug in your hard drive or something. And sometimes, doing how often will you do backups? You do them once a day, uh, once every 6 hours. Sometimes, in that space between, you can run into a problem and lose something that's really, real important to you. And create unavailability not of just data, but maybe the entire system. So in those instances, we are going to discuss some of the main techniques how this is achieved. I will just note that there are a lot of different systems, file systems, and operating systems like ZFS that make sure this is that make sure your data is redundant. But I'm going to go with the basic level, which is called RAID. So RAID simply means redundant array of independent disks. It simply means that you have multiple hard disks or SSDs. That doesn't really matter. Any data storage media. Uh, Besides that storage media that you can't use, like CDs, or that you can use, actively. You, if you have something like a hard drive or an SSD, you can introduce fault tolerance to the system by simply using RAID, which by separating, copying data and writing it to different disks can make sure that one disk drive dies, you can still keep the data. There are two separate, approaches to this. One is hardware RAID or software RAID. Essentially, software RAID is something that you can set up through software, usually through your motherboard BIOS, and you don't need any additional hardware. Hardware RAID will take a dedicated card, like you would have a GPU that plugs into your motherboard, and that will have connections for your for your drives, whether they're hard disks or SSDs. You will plug them into the drive, and you will take care of setting up the RAID array there, and all of the communication will be done through that hardware card. There are benefits to both. Software is obviously cheaper. You don't need, a separate hardware card or something like that. But hardware solutions have a tendency to be faster. And another benefit is that basically from your system, you have whatever you set it up. Like you have your system sees a single drive. It doesn't assume you have a RAID, which can help with some more exotic issues. In both of these are essentially for most users, unless we are going, really high level, they are fine. So let's talk about different RAID types. Essentially, two basic types that you're going to encounter are RAID 0 and RAID 1. One trick of remembering which is which, if you're talking about it, RAID 0 offers 0 levels of redundancy, RAID 1 offers 1 level of redundancy. Level of redundancy simply means that one drive can die, right? So we've had 2 levels of redundancy, two drives could fail before you actually incur the data loss. So RAID 0 stripes data across disks. I have an illustration later that will help you understand it. But essentially, when you have two hard drives that are in RAID 0, to you it will essentially seem like you have one drive that's bigger, that is bigger in size. So if you combine two 1 terabyte drives into RAID 0, you will get a 2 terabyte drive. If you do RAID 1, on the other hand, with two 1 terabyte drives, you will write data. Any data that you write will be written to both those drives, and those 2 terabytes of storage will appear to you as if it's only 1 terabyte. RAID 5 and 6 stripe with parity. Basically, what is parity? Well, it writes, as mentioned, when we are storing data on most storage drives, we're talking about storing ones or zeros. We're talking about storing bits. So something that we can do is, if I have two drives, one is going to have in the first spot value 1, then the other is going to have in the second spot value 0. I can write and say, is this parity, is this the same bit? So I'm going to write in chat for this. So I'm going to write something like, let's say that the first drive contains something like 1011, and the second drive contains something like 0011. So combining this, so I will say that if a parity exists, if those two drives are the same, the bits are the same, I'm going to write 1, otherwise I'm going to write 0. So I'm going to write, for the first one, they are different, so I'm going to write 0, and the others 0 are the same, 0, 1, 1, so the bits are the same. So I'm going to write all ones for that, because to indicate they're the same. Now, if these are three separate drives, very small separate drives, if I lose the third drive, that I wrote, so 0, 1, 1, 1, that's my parity drive. If I lose it, it doesn't matter. I still have all the data that is stored on the first two drives. If I lose the first drive, I can just look at the second drive and the parity bits and say, okay, if I have 0 in this spot on my real data drive and 0 on the spot on my parity drive, it means that I can just copy the data on my first drive. The drive that I lost is going to be different than what's written on the first drive, because there is a 0 on my parity drive, right? And I can recreate the first drive just by comparing those two. RAID 6 uses a bit more advanced parity distribution. Then you have some more advanced copies, but essentially you can see that these are RAID 10, RAID 50, and RAID 60, and they are copying. They are using RAID RAID 10 is, for example, RAID 1 plus 0. It means that they are using striping in addition to just copying the drives. So you get benefits of both. You get a benefit from copying that data from essentially having that striped drive, so you can increase the data storage amount that you have, and that striping will also help you with speed. For example, if you're reading, you can read from two drives simultaneously. Those of you who are listening to Introduction to HPC, you probably had mentions of how parallelization can help speed up computer processes. It's the same for reading data. It's much faster to read data from two disks at the same time. You essentially double your speed. And that's the same with RAID 5, RAID 6. You're just combining it with the striping for RAID 1. So from RAID 0. Here's how that essentially looks. So if we are talking about data blocks in RAID 0, block 1 is stored on the first drive, block 2 is stored on the second drive, and so on. Third on the first drive, fourth on the second drive. The problem with this is obviously that even though it seems to me like I have a bigger drive, if I lose one or the other drive, your data is simply lost completely. But as I mentioned, I can speed up reading because I can read at the same time from both, and I can speed up writing because I can write to two drives. With mirroring, it's simple. It's just all the data that's on here is also written on the second drive. When it comes to RAID 5 or 6, essentially you can see that we have these parity blocks separated that tell us about the parity, as I described it before, between a certain block. So we have the block 1B, 2B, and parity is written in here. You can see that the parity is written distributed differently. I use the example where a whole drive is a parity drive, that those are setups that are possible, but in RAID 5 and 6, usually you're stripping the parity across drives to induce it. Usually, one of the problems in practical use with RAID 5 and 6 is that essentially rebuilding a drive takes a long time. If you have a drive that had a lot of data on it and you want to go and take care of essentially rebuilding it, that's a problem. If you're using RAID 1, it's fine. You have all the data available to you. You just need to toss in another drive, copy all the data to the other, just so you have a backup, but the data is available. With RAID 5 or RAID 6, that's not the case. You can see that, if this third drive dies, we're losing all the data on it until we rebuild it with parity. And finally, this is what I was talking about, combining everything with 0. You can essentially see that we are combining first mirroring the files, and then or more precisely mirroring the blocks, and then combining the two to have a larger drive and other benefits of RAID 0. You can also do RAID 0 plus 1 when you first do the striping, and then you do the mirroring. It's not as common. Another term that you may hear if you're ever working with anything relating to these types of parities and backups and drives is something that's called JBOD, just a bunch of disks. And a lot of people think that, hey, JBOD will, is essentially something like RAID. No, JBOD is essentially just a bunch of disks that enable to connect. And I've seen, why I mentioned this here, I've seen a lot of people go looking for a server and purchase a JBOD, and then have because they didn't understand, then their supplier wasn't really forthcoming information to them, so they end up purchasing a JBOD which does essentially nothing. You don't run a classical OS on it. You don't run anything. It's literally what it says on the tin. Just a bunch of disks that you can that, as it says here, it's easier to implement, less costly than RAID, but you just get a bunch of data, a bunch of individual drives that you can connect to, and you can't implement any logic or redundancy without introducing additional computing resources in it. So that's something to just be careful, because I've seen two pretty large companies make that mistake here. So yeah. And finally, as I mentioned when I started, with the introduction, there are some file systems that will automatically, such as ZFS or BTRFS, it will commonly be pronounced ButterFS, such as like butter that you spread on the bread. So these are file systems that will use checksums that we mentioned last time to detect and correct any corruption, and automatically, make sure all your file is automated and will support advanced like snapshots and compression, deduplication, like we mentioned when we talked about file systems. A lot of people prefer using this as opposed to RAID, because the redundancy is software level, but it's introduced directly into your file system. You don't have to worry about any issues that could be caused by RAID. Like, for example, I actually had it happen to me, where the RAID controller, the hardware RAID controller that we had a drive from server connected to, it just died. It burned itself out, and we actually, in the process of burning itself out, it actually damaged some of the drives, and we lost a bunch of data. Luckily, that data was backed up, but yeah, it was a problem. Essentially, it took us a while to recover from that. So using something that has that integrated redundant file system would have helped us a lot, because we have a snapshot that we could just bring back. Commonly, if you're really careful about your data, you will have both. You will have both a RAID array and a redundant file system on top of it. Finally, something that I just want to mention here is essentially ECC RAM. As I mentioned, RAM can have RAM is where your computer stores all the information during the processing during your work. So like this stream is stored in your RAM at the moment. So what is ECC RAM? Well, errors happen, especially when you are doing something really, really fast, like computer processing is today. There can be errors, and just that a certain transistor doesn't get enough electrical energy to flip the bit. ECC RAM is essentially going to use additional storage and additional logic that's implemented directly on the RAM, not on the necessarily on the CPU. There are multiple implementations. There are some implementations where CPU, some of that is offloaded to CPU, and essentially it's going to make sure that all the data that you process is not there are no mistakes in the data prior to it being written to the drive. Drives are faster. You don't need so much checking on the data there in the hard drive, because it's not rewritten as often as your random access memory is. So to ensure that, use ECC, which essentially does that continuous error checking, making sure that all the data is correct, and that's usually done in large servers, scientific workstations, and any mission critical systems. So essentially anything where you don't want an error, like in banking, for example, you don't want to write the wrong value back into someone's bank account. So yes, it's somewhat slower and significantly more expensive than a non-ECC RAM, but it practically guarantees reliability against some uh, possible problems. One of the famous examples in this is one person who was speedrunning some Super Mario game, and essentially he had really great. He got really great time because there was an error. Some people say it was the error is called the bit flip. Basically, where one bit for an unknown reason that can be anything from outside electrical interference to astronomical phenomena just changes suddenly, and he got an error caused by a bit flip. It's a very famous example. So that is usually, as it says, paired with redundant storage to maximize system reliability. So it makes sure that you can check the data, and of course, RAID itself serves as an error checking system, because if you have the same data written to two drives, or you have a parity system setup, you can easily detect any error that happens if there is a change that is not in accordance to the parity that is written, or the other drive in RAID 1 setup. And there are a couple of different approaches here that I would just want to mention when it comes to data redundancy before we move on. First is data replication. There is one rule I didn't mention here. I think I mentioned it in the big data class, where it's called the 3-to-1 rule. You have 3 copies of your data at 2 different places in at least one copy on a different media. So data replication essentially means, data that is important, keep it in different locations, usually different geographical sites. If the company that you're working for has 2 offices, because problems can happen, large problems can happen, and small problems can happen. We aren't talking necessarily about uh, when you say something like this to people. uh, I had a friend, friends tell me like, oh, I have to worry about like, it's not like we're going to get hit by an earthquake or a fire or a volcano, here where we live. And but it's not that. You can have like your upstairs neighbor has a leaky pipe, and it leaks all over your server and fries all of your data. So generally, data replication for any important files is uh, strongly advised. I always tell my students, if you have some important files stored on your computer, it's probably good for you to put them on an encrypted hard drive, so no one can access them without knowing password or a passphrase or something. And then put them at your parents or your office, or give them to a friend you trust, just so you would have access to it in case something that forbid happens to the data that you have at home and you can't access it. Again, backup and recovery strategies. As I mentioned, you have to set up. The problem with backups is that they take time. So usually what you have happening is backups being done overnight or stuff like that, so they don't interrupt your workflow. This again isn't great, but what I consider more important is having a recovery strategy, where you can say like, okay, something went wrong, our data is lost. What do we do? What are the steps? Do we know where this data is written, where it should be written? How can we recover it? Essentially, when something bad happens, have a plan that you can follow while everyone is losing their mind. Then there is the concept of hot, warm, and cold data. That's essentially how important your data is to store, or how often it changes. Like, for example, something like medical data of people who are currently in the hospital. It's very hot data, because it needs to be updated very often, because those people are probably getting their their blood work done or something. The laboratories returning information to them. while the data of someone who hasn't been in the hospital for a couple of years, well, that can be stored maybe, on a system that's slower to access because you would need it right now, and then you can move it to, you can essentially warm up the data by moving it to warm or hot storage. For example, hot storage could be, when we're talking about media, it could be something like extremely fast SSDs. For example, if you are an artist uh, or you're a freelancer, what will be the projects that you're currently working on that you haven't delivered yet? Warm will be projects that you are, maybe you have delivered to your clients, but you are still waiting on, actual updates, but you're not actively working on them. There may be some changes or something, so you're keeping them close by, and call the data is something that's, project that you have completed in the past. You don't need them anymore. So, for example, for the data, it's something that could be kept, on an SSD array or something like that that you can quickly access. Warm data might be kept on a hard drive. It's slower, but it's there. It's readily available to you. And cold data could be kept on an external hard drive or a moving tape, something like that. Finally, as I mentioned, redundancy exists at different levels, whether it's a file block level or storage level. Mostly, when you talk about redundancy, today we are talking about redundancy at a storage level, right? For example, RAID. And finally, as this is like data redundancy will increase storage and complexity, and not only will increase, but it will actually decrease storage capability, right? Because if you, in a server or a server room, you have a limited amount of drives that you can put in a server or in a server rack or in a data center. Uh, like biggest drives that I've seen that are commercially available are something like 24 terabytes. So if you take a hard drive and if you put like 24 terabyte drives for something like 480 terabytes, and you do RAID 1, you're slicing that in half, right? Because now you don't have 20 drives at 24 terabytes in the server, you have 20 drives, but they are copied, so we have essentially 10 drives. And that's something that can usually be, protested by people like, do we really need it? And this is usually, protested until something goes wrong, and then everyone is happy that they haven't actually lost their data. So that's something to keep in mind, but also you don't need to be overly cautious. No, uh, it's as a data scientist, I love keeping all backups and everything, making sure. But in reality, depending on what you're working and where you're working, some data isn't that important. Obviously, if you're keeping it, you want to keep it somewhat safe, but having something like snapshots or occasional backups are fine in some cases, and that's something you need to decide on case by case basis. Okay, before I move on to a different topic, you will just give me a brief second. Someone knocked on my door, so let me just tell them that I have a class. Here I am back. I apologize. Some of my students seem to be very interested in talking to me, probably because an exam is near. So I apologize for the interruption. Okay, so we have covered essentially how the data is stored, what are we storing the data on, how the data should be stored in a safe manner. So let's talk about how we can transfer data, because having data, just on our own without anything really isn't going to be useful. we need to be capable of sharing data, uploading the data somewhere, etc. So in this topic, I'm going to essentially describe a bit about how internet works, how just to be able to discuss it, some basic terms, etc. That's the point of this, and we are going to mention a couple of essentially protocols that we can use to move data. We're going to describe all of those terms. So let's start talking about the OSI model, which describes internet layers. So we have a physical layer, data link, network, transport layer, session layer, presentation, and application layer. Application layer is what we are seeing right now. Teams is something that exists in the application layer. Presentation layer is the layer is a program programs that essentially translate the data that comes from the internet into something that, for example, it transforms the ones and zeros of this stream into a video that can be shown. Session layer assures that communication can be done between applications. You don't want to have your applications that essentially exist widely be able to do anything, send it or receive any data. You essentially want to have a bit more control over that. Transport layer actually transfers data, right? It defines the protocols that allow you to transfer data. And network layer finds essentially where the data should go. So when you try to send me your file, the network layer figures out where the data needs to go to, and data link. And let me just, I see some questions. So yeah, node links are going to be shared. All so this is in the PDF that I shared last time. I can share it again, just in case someone wasn't here yesterday. But essentially all the drives, all the entire lecture is in that PDF that I sent you yesterday. I did slide 72. So I will reshare it just in case. Okay, I will keep going and post it in chat. Basically, the data link and physical layer are data link is basically electronics that control basically your how your Wi-Fi works, how your internet works, and the physical layer are actual physical devices like the cable that you are transferring data over. And this essentially helps us, separate each part. Why is this important? Why is this interesting to us? Well, because not every engineer is going to take care of everything. If I am developing an internet application as a front-end developer, I don't want to worry about, well, how am I going to send packets over Wi-Fi? If I am, writing something, really complex like assembly code for transferring bits over Wi-Fi in a secure manner, I don't want to think about, oh my God, how will that data be translated? I just want to focus on my part, and it's much easier to separate this. Of course, as with every standard, there are different models. Another model that we have is TCP IP model, which basically combines certain layers. So it contains a network interface, internet layer, transport layer, and an application layer. It basically simplifies this previous OSI model, as you can see here. It says, okay, session, presentation, application, that's something that's going to be taken care of separately. We don't care about it. And data link and physical, you can't design an antenna for Wi-Fi without knowing how the data is going to be transferred. What kind of elements need to be sent, what kind of frequencies are needed. So let's combine that together. Network and layer are, in transport layer are, we're going to remain them the same. And then the session that's going to take care of connecting. So each application that you have, like Microsoft Teams here, is going to take care of its own connection, etc. This is essentially the TCP/IP is essentially what we are using today when we are talking about networking. If someone ever asks you about internet layers, they probably mean about TCP/IP. But the same model is also useful. It's just that TCP/IP basically says, hey, the application, once you got the data, we expect you to be able to figure out what's written in there and how to present it to the end user. While something like OSI model might be more useful if you are working in development for the specific, you're working in a company that does specifically internet applications. You will probably have different teams for session presentation and application tasks. Okay, so something that I will mention a lot and that you will hear mentioned a lot if we're talking about networking is ports. A port is defined as a logical input for communication in network unified by a number 0265535 65,535. The reason for this is a 2 to the power of. Let me just. And it's essentially no, okay, so it's 2 to the power of 16. You have 16 bits for the source, 16 bits for the destination, and that's essentially why this number is 65,000, because 2 to the power of 16 is going to be really close to it. So essentially, what is a port as a project endpoint? Yada yada yada. It basically means that if I send your computer a piece of information, your operating system, your computer doesn't know what you're looking for, right? It doesn't know because right now, some of you probably have these Teams open, and you probably have a ton of other applications that are using the internet. For me, for example, I have Skype open, I have Discord, I have my Mega backup, I have Steam, I have this, I have that, I have NVIDIA GeForce. Yeah, I have a lot of communications coming to my computer and going from my computer. So how does my operating system know that when a piece of data arrives to my computer address, to my IP address, which is unique address of my computer, how does it know what is what? How does it differentiate between the the data that belongs to this Microsoft Teams stream versus the update you're downloading for a game stream? It basically knows it through ports because Microsoft Teams is going to use port 20,000, and any information that's sent to you from the server, right, that I'm streaming this to, is going to essentially be sent with a note that, hey, this is for the port 20,000, whichever. Right? There are certain ports that are essentially reserved or at least well known, assumed HTTP, HTTPS, and FTP are at the given ports. SSH is as port 22. We're going to discuss what these protocols are. You have certain registered ports which are essentially assigned to specific services or applications from 1024. So anything higher than these well-known ports, which are also registered port but reserved for anything, ports from 1024 to 50,000 are registered for specific applications. And then dynamic or private ports above 49,152 can be used temporarily. If you're programming something, if you're writing a piece of code that communicates between two computers, you're probably going to be using some ports in this range. And as mentioned, they are essentially used for routing data to the correct service. So here's an illustration, if both Jack and Will here are sending data. Once it comes to this big internet machine somewhere in the cloud, it wants to know, based on the port, what kind of service it's actually going to be forwarding that data to for processing. That's essentially what ports are. You can think of ports if you live in an apartment building. You have the apartment building, and then you have, depending on where you live, you have either an apartment number or your last name, on the door. That's essentially what ports are. So when I send a parcel to your IP address or your home address in this metaphor, the delivery guy won't know if I just write, for example, my address here, my office is Bucharest 58 in Croatia. I want to, the delivery guy won't know anything. You need to write my office number 257 for that information to actually reach me. Okay.
Excuse me, can you repeat what you say about the cloud? You mentioned somewhere about the cloud.
About the cloud, so I essentially just use the cloud as a example. Cloud is essentially just a computer somewhere. We will talk about specifically more about the cloud, but essentially when I'm at this point in this presentation, if I'm using the term cloud, it's essentially the same as using as talking about a distant computer or a server.
Okay,
yeah,
fine.
so
Okay.
yeah, it's my mistake. There is a difference in essentially in these layers in how it works. Cloud is differentiated through this application layer, but because different things are done on cloud. But essentially, if I accidentally use it again, you will. Yeah, it's the same as me using a computer somewhere else.
Okay, thank you.
Okay. So let's talk about data transfer protocols. So essentially, data transfer protocols are algorithms. They are just full protocols to help us differentiate that basically tell us how to send communication, how to send something. And you can think about protocol again. This all comes from mailing. That's when that's where all of this comes. So if you want to send mail to someone, right, you need to write the letter, print it out. You need to put it in an envelope. You need to close the envelope. You need to write certain information on the back of it. You need to stamp it, and you need to put it in an outward box for sending. That is the same thing that essentially exists with internet protocols, depending on what the protocol is trying to accomplish, because not all internet communication is the same. In some cases, we care a lot about our internet communication being safe. In others, we want to guarantee that you get the data and that exact data. In some cases, we don't care about any of that. We just want you to get the data fast. So there are different protocols that define this, and there are honestly a lot of protocols. You will usually find them introduced with something like this, like FTP, HTTP, TCP, IP. So P stands for protocol. Another thing you may see is something that's called RFC. RFC is essentially something that looks like this. So essentially, this is something very old that's called a request for comments. This is from 99. And essentially, it was the initial way these protocols were developed. Someone would write and describe the protocol, put it online, and put in this RFC request for comments, and people would comment on it. And once everyone was happy about it, they would lock it down and say, "This is the protocol we're going to use." In case you are interested in how many protocols are, and there are literally thousands, and we aren't going to talk about any of them. They're actually, I'm going to share this one fun protocol that's called IP over avian carriers that actually defines through RFC 1149 how to transfer data, internet data, using pigeons, using pigeon mail. And yes, you can actually implement it. So it's not really, so there are a lot of that is obviously a bit of a joke. It actually exists as standard. It's defined as a standard, but no one actually uses it. But yes, there are thousands of different protocols. We are going to mention some of them that are really common that you are probably used in your day-to-day life, even if you aren't, a computer scientist. So basically, as I said, what you want to accomplish with data protocols is make sure that when I'm sending you data, right, you know what it is. If you are expecting a letter, it sounds very basic to us, but if I tell you, hey, expect a letter, you know that once you receive the letter, you can open it and read the information. But that's intuitive to us because that's something that we have been taught since we were little. But if someone never saw a letter before, you wouldn't know what to do with it. You would look like, oh, it's some sort of envelope. I don't know. I don't want to tear it up. And that's basically same with data transfer protocols. If I'm sending you data in a certain way, you need to know how that data is structured and defined so you could unpack it and figure it out. Or we want to ensure that data integrity through things like checksums that I mentioned. Same goes for error detection and correction. And finally, we want to optimize bandwidth usage. Here is an example. I can always send you the to make sure you get it. I'm going to send you this email 100 times in a row. Okay, but I'm going to send so much data that I'm going to congest the traffic, right? And just to, this is the term that I haven't mentioned before, bandwidth. It just means how much data can I push through a communication channel at this time. So, for example, your internet has maximum speed, and you can, for example, right now we have 50 megabits or 100 megabits, and this means what's the fastest that you can download. Bandwidth tells you, okay, maximum speed is this, but it's also like the maximum that enables you to download at the current time concurrently, right? So you won't necessarily be able to get your maximum speed from one source, so you may spread it across different sources. Let me explain it with a metaphor. It's going to be clearer. If we are driving a car on the highway, the maximum speed that you can go with is the transmission speed, and the bandwidth is the amount of lanes that you have on that highway. So if you have a bigger bandwidth, you can drive multiple vehicles at the same time. So yeah, so let me just explain that term. Okay, let's talk about some protocols. I'm going to start with FTP, just because we're talking about data and file transfer. Essentially, FTP operates on ports 20 and 21, so you can send data, you can send individual commands. For example, FTP will allow you to connect to a remote server and essentially create or control data that exists there. Usually you have something like SFTP that doesn't operate on separate ports, it operates on a single port. And it uses something that's called an SSH protocol. SSH essentially allows you to connect to a PC and control it, work with it, enter commands into it, and read the output it gives you at a text level through a command prompt if you're using Windows, or terminal if you're familiar with Linux or Mac. So essentially, SFTP is what's generally used today for transferring data. And similar, let me just open up. Okay, I think some issues connecting to the server, but this is essentially what FTP software uses looks like. Here you can type in, your password, connection. That's why it didn't work. Okay, something wrong with my server. That's not that important, but essentially in the same way, I have information here. I would have information on the server, and I can easily transfer the data from here to the server, just drag and drop it back. With something like SSH that I mentioned here, SSH allows you to enter commands. So for example, here, let me connect to a server. Okay, this one works. And I can enter, separate commands and use that remote computer as if I'm using a local computer through an interface like this. I also have SFTP here, so I can connect to host here, and here I have some information, so I can just download the data like this or upload the data to the other side. Okay, I'm obviously running into some protection issues because I'm connecting through a VPN, but essentially I can drag and drop information from a remote computer to me. That's obviously extremely useful, and we can, and being able to transfer data in a somewhat secure manner is very, very important today. That we can, and essentially, whenever we are downloading something over the internet, we are probably using either FTP, depending if it's not something that's very important, or SFTP to download it, or some sort of a torrent protocol. Another thing that you are using very often, whenever you're connecting to the internet, is HTTP. HTTP essentially forms the foundation of World Wide Web, as it says here, and it is essentially what allows you to transfer HTML code from any server to your machine. In the same way as FTP had a secure variant, we have figured out that we need a secure variant of HTTP to actually connect the information to connect securely, and essentially HTTP, once you add a certain layer of security that checks, essentially the goal is to validate whether the person that you are connecting to is actually the person you are connecting to. So in this example, if I say I'm connecting to Wikipedia, if I double click here, we can see that I have HTTPS, and that means that whoever is hosting the website paid for a certificate that integrates this and guarantees them as the organization that is Wikipedia. You can just buy it and not be the person that is. They are pretty safe about it, and of course you can run into some problems maybe happen to you where you typed in, when you went to a website and said, hey, there is a possible risk ahead, or something that usually means that the server is stating to have the HTTPS, or you are trying to use HTTPS, but the website actually isn't secure. They don't have the updated certificates for HTTPS, and you can't necessarily use it. When it says, it operates in port 443, this simply means that between the server and your computer, the communication is accomplished using this port. Okay, so one of the super important protocols, basically how important is, you see that I mentioned, like, I called the internet before, like the basic structure, I called it TCP IP. Basically, TCP defines how the actual data is transported. So for SFTP or FTP, HTTP, HTTPS, these are all protocols that define how the data is going to be packaged, how it's going to look, what's going to be contained, is there going to be a certificate, is there not going to be a certificate, etc. It's all built upon something, and essentially there are two essential data transfer protocols, that's TCP and UDP. We're going to mention UDP later. TCP is a transport layer protocol. So as I mentioned, it's not higher, it's not the application layer or something like that, like HTTP. Protocols can exist in different layers. And TCP defines on the transport layer how information is going to be transferred. It is connection oriented, so it means it has a handshake, uses sequence number, and essentially what it tries to guarantee, what it does is essentially it makes sure that the data you're sending, so if I'm sending a piece of information with TCP to you, that piece of information is going to include certain other information. So there's a bit of overhead, a bit of additional data included in what we call a packet, right? Because this block of data, like, I don't know, 24 bits that I'm sending to you, I'm including on top of that some additional bits to essentially provide information. And what is that information for TCP? That information is basically includes who is sending the data, what is my address, who that data is for. So if you accidentally receive data that doesn't belong to you, you can discard it. And it's going to include the number. So the data that I'm sending you, if I'm sending you a piece of, a text, for example, and each block is a letter, it's going to guarantee that each letter arrives to you in the correct order, so you can actually have a full sentence reconstructed. And you can see here, I'm not going to go into this state machine of how it actually works, but it actually uses this ACK is just a confirmation. It can handle timeouts. It can handle FIN, which is a signal that connection needs to be end. It can sync communication, etc. It's a very complex protocol that has a lot of possible communication between just listening and sending data. So there's a lot of information here that will serve to establish in the first step, it will establish the connection between, for example, my machine and your machine. It will make sure that we both expect this, and then it's going to start sending data. And once it sends a piece of data, this is important for TCP, it's going to wait for you to confirm that you have received it, right? So if I'm sending you over the word data, I'm going to send you, first going to ask you, hey, are you expecting to receive some words from me? You're going to say yes. I mean, your machine, the program implementing TCP, and it's going to say yes. It's going to send an ACK symbol, acknowledged, like we want to continue with the communication. Once I have confirmed that, I'm going to send you the first letter, and I'm going to ask you, like, hey, this fine? Is this the letter that you were expecting? Is it the first letter, and can you confirm that you received it? If you don't receive it, if I don't get your response in time, if I don't get that acknowledged symbol, I'm going to send it again. If you tell me, like, oh no, I received something out of order, I received letter D as number 1, and then I received letter T as number 3, there was a mistake. Can you make sure to reconstruct this? Or I won't even start sending additional letters until you confirm everything. There's a lot of possible checks there that guarantee that basically if I send you the word the ATA, you are going to get each letter in order, and that creates overhead, but it almost guarantees that you're going to get correct data. UDP doesn't care about any of that. UDP essentially says, hey, I don't care. I'm going to, you have your IP address. I'm going to send the data there to a port that you told me to send the data to through the, an application protocol. And that's all I'm going to do. I'm going to send one packet, another packet, a third packet. So you can see that in the process here. So I'm sending first this synchronized that I'm basically checking, like, hey, are you okay? Do you want to receive this data? Are you expecting this data? And then you send me like, oh yes, I want to. Then I'm going to acknowledge that. And I haven't even sent you the first letter yet. With UDP, I sent you the letter D, I sent you the letter A, but the problem is that this data can be lost. So why even use it if we can lose data? sometimes we don't care about losing data. If I'm streaming you this video, right, and I'm streaming it at 30 frames per second, I believe, do you care about losing a frame? You won't even notice a single dropped frame in this communication. Same goes with, if you're watching a YouTube video or you're streaming music or you're collecting data from a remote sensor somewhere. It doesn't really matter that much. If you want, it's much more important to you. For example, let me use video as if you're watching like a movie, it's much more important for you to get all the frames at a high enough speed so you can enjoy that 30 frames per second or 60 frames per second or higher, instead of making sure that each frame is in exact order. So if you drop a frame or if you receive a frame out of order or something, the reality is you probably won't notice, especially since you usually won't communicate at the level of frames. You're going to communicate at a much lower level. So you might get in a frame a couple of mistaken pixels, which you probably won't notice due to compression, etc. So that's why UDP is commonly used. Basically, if you care about fast communication, use UDP as a protocol. If you care about secure, not secure in terms of security, but I want to guarantee it gets there, then you're going to use TCP. It's the difference between sending mail normally and sending a registered mail that needs to be signed, etc. Okay, so there are additional information that you can use essentially when you're throwing HTTP. Again, you may need to want to transfer data over HTTP over a website. Well, every website is essentially transferring data because you are downloading, a website that's formatted in HTML. That's similar, to JSON and XML. It's essentially website, but you can actually send real data. You can send additional data. For example, not anymore because it's not really safe. But for example, logging. If you're logging in your username and your password, you can send that with post communication. You can send that to a server, and it will allow you to log yourself in. This can be intercepted, so it's not really great for that. But in some microservices, so microservices, like a really small piece of code that is essentially sending information to you over internet, it's usually very limited, doing a single thing, etc. You don't really care about, safety that much. You just want to, communicate. For example, one basic example could be me sending you reading the temperature in my server room. Okay, I don't care about someone intercepting it and learning that the current temperature in my server room is 20 degrees Celsius. I can just receive that information and not worry about like setting up a very secure transfer. So I can just use something that's called REST API. API stands for Application Protocol Interface. So it's a way that I can communicate, with a given application, and I can get that information using basic internet infrastructure. I mentioned NFS previously. It's when we're talking about file systems, but essentially you can use it. It's one of the examples of protocols that allows you for remote file access. What is the difference between it and what I've showed you before, FTP? Well, with FTP, I needed to open up a piece of software, and do something to make sure that my that I can actually connect to the server, and I need to use a separate I need to essentially use a separate piece of software to achieve that. With an NFS, I would essentially have a third hard drive here that I could just access like I would normal data on my local machine, and that usually operates on port 2049. Same goes when I was talking about NFS. I mentioned Samba server message block that is more commonly used in Windows, right? Okay, SSH, as I mentioned before, is one of the most commonly used tools that when you are administrating a remote server. You have probably encountered stuff like VNC-based stuff like TeamViewer or AnyDesk that basically allow you to remote and use video. That's not always great for everything. It's very useful, if you need to do something to your computer at work, or my mom forgot her password and can't log in, so I'm going to connect over AnyDesk and make sure to reset her password for Google account or something. Okay, but for most computers, data servers won't have a graphical interface, right? All that you can get when you connect to most servers, is going to be a terminal like this where you can type in information, and basically SSH allows us to do that. As I showed you before, let me show you again. When I'm connecting to SSH to a machine, if I know how to use Linux and navigate, I can basically do whatever I want with this remote. So this is a computer this is a server that's located downstairs in our server room. I can see nothing is running right now. I can see all the cores and everything. I can run Python, do stuff like as if it was my own computer, right? And check what's going on, see if anything's happening, and use it practically normally without any graphical interface. But most servers wouldn't offer me graphical interface anyways. Okay, so that's why SSH is super important. And if you're ever, administering, for you who are into computer science, you will probably encounter SSH somewhere in your life, especially if you are more focused on computer administration and system engineering, stuff like that. Okay, so I mentioned last time that security could be a course on its own. We are talking about the security or preparing course for that, but I will still talking about it. I think talking about transferring data, accessing data remotely, etc. It's important to mention certain problems and what to watch out with data security, just so when you get out of this class, you have a certain knowledge regarding general terms of security. I won't teach you any, anti-hacker techniques or any detailed protection techniques, but I'm going to show you some information essentially about data security. So, as I said, data security aims to ensure confidentiality, integrity, and availability of data. So, confidentiality means that if I'm sending you data, I want it to remain between us. Integrity means that I don't want that data tampered with. So, if I send you data that says 100, I want you to get 100. I don't want that due to error to become 1010 or due to someone interfering becoming different. And finally, I want availability. If I'm connecting to, that's one of the most common actually attacks is something that's called like a denial of service attack or distributed denial of service attack. If you're hearing news that a certain website has been DOS or DDoS, that basically means that people have performed that denial of service attack, which won't necessarily target confidentiality and integrity, but it will make sure something is unavailable to you as a service online, so that can lose a lot of money for people who are using the service or for people who are hosting the service. So it's very, very common attack and something that people will try to navigate around. So yeah, as I said, we don't want unauthorized access to our data. We don't want the data to be tampered with, and we don't want to lose any data that's being transferred. So as I mentioned before, SSL TLS exists, encryption, authentication exists. There is a difference between terms, if you hear, so like authentication and authorization, they are interchangeable. A lot of people, even me, will make a mistake of using it interchangeably. Authorization means that so authentication means that I'm making sure you are who you are. You know, if you come to me, let me pick someone's name. Lucia Milohnic. So if Miss Milohnic comes to me and says, I am Lucia Milohnic, or I'm going to check, I can check that she is who she says she is through a certain system, that maybe through password, or maybe she's going to, show me some a certificate or something that her ID that makes sure she's who she says she is. Authorization, on the other hand, means okay, I have identified myself, but that doesn't mean I can do whatever I want. If I'm a professor at the university, or a teaching assistant like me, or a student, no matter if I walk into the university and the guard at the entry lets me in because he knows that I am Sandy Baresi Shigota, that doesn't mean I can do everything that a professor can do. Same goes for students. I can walk into the student administration and say like, hey, I need a grade changed, and they're going to change the grade because I tell them I made a mistake. I'm really sorry, but they're going to check if it's my class, right? So that's authorization. It's going to make sure that a student who walks in after me and tells me, "Hey, I want the grades changed," they're going to tell me, "Hold on, you belong here, right? You can enter student administration, but you can't change a grade because you aren't authorized to do so." So that's something that's commonly mistaken. In talking, I do the mistake myself. Okay, so and usually when it comes to personal information, financial transactions, and especially medical data, that's where data security gets put under spotlight. So I know that it differs from country to country. We have people in different countries. Us in Croatia, since we entered European Union, we had to straighten out a lot of things about transferring data. I heard stories. It never happened to me. I'm not that old, but I heard stories of some people that I work with, receiving like Excel files with information containing personal information of patients because they were working with hospital. That's that's horrifying. That doesn't happen anymore today. At least it doesn't happen with people where I work at. But yeah, it's not always malicious, right? It can just be like people don't understand that that's a problem. I talked to doctors in the past, and they tell me like, what's the problem about you knowing, this person's entire medical history? Their name isn't that important. You don't know who they are, just by name. But yeah, we need to, protect personal information. That's what's required. So it's not always malicious. Data is not always leaked maliciously. Sometimes leaked because people don't think it's important, or the doctor uh, exports outside of their system. They export a full table with names and personal identification numbers and so on. They copy the file, delete the names, and then send the wrong file. Uh, what I'm trying to illustrate here is that data security, you don't need to fight. In most cases, you aren't fighting malicious actors. You are fighting people who make mistakes. On the other hand, some other countries are extremely stricter with data. For example, in Croatia, if our each hospital has an ethical committee that's going to decide like, oh, can data be shared with these people? and they will say yes, if as long as you anonymize it, if that person is someone who works for any university or a company or something like that, if there's someone who has the right to access that data. But for example, I worked with a hospital, university hospital from Denmark, and they weren't happy about sharing their data, especially outside of country. Working with, I worked a lot with colleagues from Kragujevac. Kragujevac here, they sent me a lot of, we shared a lot of data, over country lines, in an approved manner, because it's not that big of a deal. But for example, for Denmark, the rules are so strict that essentially what we did in the end is they encrypted all of the data, put it on a hard drive, and mailed it to me. They didn't even send it over the internet because they weren't they were scared that someone might access it inappropriately if they give me a password to their server or something like that. So they just downloaded everything, put the data on the hard drive and mailed it. And after a year, I got a call and they were telling me like you need to delete all the data, and I told them like, but we are still in the process of publishing this research that we did. Like, can I keep the data for a couple more weeks so I can make sure if there is any problems with the paper, I can actually correct it and so on. And they told me, no, you need to delete, you need to take that hard drive and delete all the data of it, of any computer, of everything. It probably won't happen, but like we can actually request a check that you give us access to a computer so you can make sure you deleted it. We got lucky. We didn't need to change anything in the paper except one little thing, and that was that they wanted a picture of an X-ray. And they didn't have pictures of, there were knee X-rays, and they didn't have those pictures available to me, so I actually had to use my own from when I got injured, and I had to put it in the paper as an example of what a knee X-ray looks like. So that's a bit of a story regarding that. And yeah, so sometimes internet isn't even an option for sending data. So when we're talking about security threats in data, there are four categories that basically cover all the possible threats to data safety. And these are eavesdropping, data tampering, replay attacks, and denial of service attacks. Eavesdropping happens when I'm listening to you. So it's essentially if you are sending information, you're sending it over the mail server that I have access to, they gained access to in some way. And it's not encrypted, or I know how it's encrypted, I know how to break the encryption, I can just read it. Data tampering would be if I'm, you're sending an email and you're telling your friend that, hey, let's have a meeting tomorrow at 3 o'clock. Instead of that, I changed the time when that changed the information in the email, so you miss the meeting or so on. Replay attacks are essentially similar to data tampering, but the goal is for me to intercept the data, and I still send you the valid data. So, and they're very problematic because from your perspective, you didn't receive any problematic data or anything. I have actually just retransmitted the data. I'm going to illustrate it so it will be clearer to you. And finally, denial of service, as I mentioned, it is when I want to make sure you don't get access to something. So, for example, this is, there are a couple of types of these security attacks. We're going to talk. One of them is fabrication. So I am pretending to be someone else. I'm pretending, in this case, to be Alice. I'm sending some information to Bob. And this is usually commonly used in something that's called phishing, where, for example, I can send you an email pretending to be your bank. I can, for example, buy a domain that's very similar in name to your bank and send you an official looking email. I can connect you to a website that essentially looks like your bank website. And once you type in your login information, instead of going to you're getting logged in, that information sent to me, and the website usually either connects to the actual website. So from your perspective, you have been connected to the website, but I essentially performed a man-in-the-middle attack and listened to and got your password login by pretending to be you. And this happens to a lot of people. YouTube is a popular target lately. A lot of YouTubers, get something like this sent to them, and then they get their entire YouTube account stolen, and you end up with like crypto scams and stuff being promoted on there. So that's phishing, and that's something that happens, and it usually aims at less technologically aware people. But just because you are familiar with computers, you can fall as a victim to it. Then we have something like this, which is just an interception. I'm not doing anything. I'm just getting this message. You are still getting the message as normal, except that information has been shared with me now. And depending on what information is sent here, I can get further access. If, for example, Bob asked Alice, "Hey, Alice, what is your password? You are on vacation. Can I please, log in to your account?" If I can read that, if Alice does send him the password, I can log in without her knowing. Interruption, again, this is the denial of service, where it's an attack on availability. If information is sent here, I stop it in some way. Maybe I break the server so you can get the email, or unplug the cable or something. And this can be crazy effective, especially when combined with this type of attacks, where if I have your bank account password, I know that if for example, my bank has, whenever a certain larger amount of money is used from my account, I get a phone notification. So even if I stole I stole your information, I go to an ATM, I pick up, a couple thousand euros from your account. If you get a notification, you're going to stop it. You're going to call your bank, say, "Hey, I didn't do that," and depending, on your bank policy, you might even get that money back. But with interruption, if I combine interruption, so you don't get once I'm in your account, in your bank account, I go somewhere and I click like I don't want to receive information. So it doesn't have to be, a high tech thing where I'm like hacking mainframe somewhere or something. I say like I don't want to receive information in your in your account about my account, about spending, and you don't get a notification, and it can do a lot more damage because now your bank isn't going to tell you that I'm actually accessing your money. And third is modification. As I mentioned, it comes here, and I intercept the message, and I send you a different message. I said maybe I sing, let's meet tomorrow at noon. I intercept that and tell Bob that Alice, and Alice thinks Bob thinks that Alice told him like, hey, let's meet tomorrow at 1 p.m. instead of so this can also be very, very problematic with something like especially medical data or something like that. Can you imagine, your hospital sending information telling you need to come in for an immediate treatment? Maybe there's something wrong with your pacemaker, and there's maybe the biopsy came up positive or something, and I intercept that, tell you everything is fine. It's a very, very scary attack pattern. Okay, so I mentioned encryption a lot. I mentioned it last time as well. So essentially, encryption is me modifying a piece of basically a message or something in a way that changes. There are a lot of ciphers and a lot of stuff, that can basically represent encryption. It basically means that hey, if I am moving something, like for example, this is one very simple example of encryption. We have text. We had everything confidential to say. He wrote it in cipher that is changing and we are using something that's called Caesar cipher, which is essentially just shifting a letter. So A becomes H, B becomes I, etc. We are just shifting the letter, and we can say that I became P, if became M, right? So that's essentially just a very very simple example of encryption encoding here, and you can see that we have something like more advanced, like AZ126, which turns this into numbers. This is great because I already need to turn this into numbers to send it via the internet, right? So I can use something like A176 route 13 is similar to Caesar cipher. It just uses a 13 rotation, etc. Like there are a lot of examples that you can use to encode or decode something and encrypt something. Usually, the difference between encoding and encryption is that if I know I started with Caesar cipher, if I know that this is shifted by 7, uh, I can know that this letter is I. I can easily go back from this to this. Encryption usually implies that in addition to this algorithm, this is an algorithm, right? I'm taking a letter from here and moving it by 7 spots here, right? That's the algorithm. It's a simple algorithm, but it is an algorithm. With encryption, usually I'm going to have another piece of information. In addition to knowledge of algorithm, I'm going to have a password or something that's going to uh, enable not everyone to get this. So right now, if I send you this, someone who is smart enough might recognize like, okay, this is language. It's probably some sort of code. I can just take that message here, uh, set it for decoding, and I can get the text out of it, right? But if I used some sort of a secret key to encode this, well, you would need to know not only recognize what type of cipher was used, but you would also need to know that key, and that is what encryption is. So you can see that there are two basically approaches. There is symmetric encryption and decryption. So, for example, this means that you have a single password uh, to use both decrypt and decrypt. Uh, this is, well, it can be a bit problematic because now we both know this thing. I'm going to use this. So, for example, quick brown. So I can, encrypt this with certain secret key. And I'm going to set the secret key to, I have no data. I won't set data because it needs to be at least 16. This is, okay. I need to use it. My apologies, I need to use it. Something like this. Okay. So what happened now? Now I turned this text into this text, right? Now I can't, as I did before, just paste this and decrypt, right? I need to enter a secret key. If I don't know what the secret key is, and I try to guess, you can say that there is an error or something, an issue arised by a bad key during decryption, etc. I need to know both this algorithm that's encoded into this website and this secret key. Get the text back. Okay, so what is so this is what's called symmetrical encoding. Usually when I'm using symmetric encoding, I would tell you the secret key in some way. So maybe I would communicate it to you in person and then send you information online so you can actually use it. So this key needs to be separate, but the problem is that this key needs to be sent to you in some way, and I don't know if that's going to be safe. I can't guarantee if you are in United States of America and I am in Croatia, I can't meet up with you and whisper it to you. So I need to send it through some channel, and that channel may also be compromised, and we don't know. We don't know that that this won't cause a problem, and actually leak us. But this is the example, that we have. This is the example that you can have encryption. So we have an algorithm and you have key. That's, as I said, can be problematic because we have a single key to encrypt and decrypt. What if we use something like asymmetric encryption? So now we have a pair of public and private keys. Let me just. So doing that same tool, I can now generate key pair, right? So this is a public key, this is a private key. Private key is my own. I won't tell it to anyone. Public key is, I can share it. I can post this in my email at the bottom because it's public key. So what I can do now, if you want to send me a text and you want it to remain private, I can use this public key, right? Okay, it's already entered. And I can encrypt it into something. And now I am the only one who knows this private key. I keep it hidden. I can decrypt it. So what happened here? So you want to send me this message. I can send you this public key and tell, hey, this is the public key. Can you please just unlock this? Can you just use that? If I use a different private key, if I change just a single letter, just this first letter, I will change to A. It's mistaken, right? It's a mistaken format, but even if we have a wrong key, I can. So you can look the message for me using my public key, and only I can figure out what it is using my private key, who no one else knows. Now we have an asymmetric encryption that's secure for both of us. And when I'm sending you the information, we can repeat the process. I'm going to use your public key, and you are going to use your private key to decrypt it. We can also use that for signing. We can also use that to sign information. We can also use that so I can sign something, lock it with my, if I give you with a private key, right, it has been sent for me because I can use my both this private and some algorithms will, not all algorithms will allow that, but depending on some algorithms, private and public keys are interchangeable. So I can encode something with my private key, you never heard it, but you can decrypt that with my public key. And doing that, because you know that my public key works, it's unique, it won't, because of how the algorithm is designed, you won't accidentally, it's like a fingerprint, you won't accidentally be able to unlock it with a random someone else's public key. So I can, if you receive a message from me and I use the public key and use my public key that is shared with you publicly, I post it on my website, you can guarantee, okay, that is actually his message. If I send you a message from my email and it's encrypted, and you try to unlock it with my public key and it returns you an error or it decodes to something that doesn't make sense, you can say, okay, someone got into his email and try sending a message without access to his private key. Okay, I mentioned SSL TLS, and basically it it's the same protocol. TLS is simply updated to check their certificate based. Certificate simply means that I give you something like your ID. You know, if you have an ID in your country, it's a government issued certificate that says that you are who you are. You know, person whose picture is on this ID, who is in possession of this ID. This is their name. This is their, and I can use it to check information about you. Same things happens with certificates. You know, for computers, except they are issued for a given website or a given server or a given application, whatever can be set up. Okay, so what are some best practices for securing data transfers? We have, you know, using strong encryption protocols. Commonly, you are going to use today private public key, so asymmetric RSA locking, because of that problem with you know, symmetric locking, where you essentially need to share that private key separately. Another element that is very common today that I suggest you use is using multi-factor authentication. I just want to clarify something. It's a big error that I often see with people. People tell me, "Oh, I'm using multi-factor authentication," when they aren't using it. Why?
Can I make another question?
Yes, go ahead.
Do we know which protocol does it use? The WinTransfer, you know, how can I describe it? It is an application. It is this platform. What is it?
Are you trying? Let me see if I don't quite understand the question. Do you mean like, how do we know which like
there is an
encryption?
application or something that it is called WeTransfer, and we use it
WeTransfer.
to yeah.
Yeah, sorry, I didn't understand what you're talking about. I know what WeTransfer is. I just thought you were saying. I don't know which protocol actually uses. Let me see if we can. But yeah, it's okay. So yeah, it's encrypted using a TLS protocol that I mentioned it before. Okay, so according to them, using here, let me just open it. That's a great question. So you can usually find out good companies are going to tell you what they are using for security. And then if you know some knowledge, they're also going to tell us stuff like this. We fulfill GDPR, Dutch AVG standard. Even better, it would be they probably didn't want to like, you know, cause issues to the site, but it would be much nicer. They actually have a link to their certification for this. But okay, but they tell you, you know, that they are using when they're being transferred and when they are stored. So their transfer security is guaranteed using TLS, and yeah, and when they're storing, they're using ICE. So they're using that symmetric, as I mentioned, they're using, because for storing, you don't need to have a public-private key. You can just use a single key, a single password to store something. But it's a really great question, because yeah, if you can always find this out for platforms and generally, you know, go into bigger depth and see, is this a good algorithm? Isn't it? What are the possible problems? Something, especially if you, it's good to check, especially if you're sharing, you know, something that's relatively private through any platform online, because platforms can have issues, especially if they're just slapping like, "Oh, we are secure" on it. Good platforms will tell you exactly what they're doing to do. There's a concept of that's called security through obscurity, where basically tells you like, "Hey, I don't want to tell you exactly what I'm doing, because I don't want you to know. So they want, for example, they just told us we're using TLS, but they haven't gone into detail about, what kind of TLS are using, how they're doing the encryption, etc. Because that would help you possibly break that encryption. But generally, some level of informing is to be expected. Don't let people tell you, oh, no, it's just obscure because of security, and we won't tell you anything. So yeah. Okay, that's again great question. Thank you very much. So back to this.
Thank you for your reply. Thank you.
No problem. For this multi-factor authentication. So what do I mean by multi-factor authentication? So you type in a password to your Google account, and it tells you like, hey, we sent a text message to your phone. Type in the code, right? Or through your application on your phone, we are displaying a number that we need to type in here. So we aren't using a single factor, a password. We are using multiple factors. We're using a password and access to our phone to guarantee it that it's actually us. So what is the problem that people usually do with multi-factor authentication? It's that people will, for example, use two passwords. They say that's something that I hear a lot. I use multi-factor authentication because on my phone I need to type in my PIN, and then I need to type in my password for my email, or type in my password for my computer and then password for my email. That's a single factor. When it comes to factors, there are three factors that you can have. It can be something that you know, something that you have, and something that you are. So something that you know is a password or a PIN or a secret web address that you are accessing. Something that you have is, for example, a USB key that you plug in and it verifies, a certificate that you have stored on your computer, or your device, your phone that you have access to. And three, something that you are is biometry. So, for example, your fingerprint. It's very common. Less common is like your voice analysis, and in movies and some really safe places, it's like a retina scan or something like that. Generally, having two passwords isn't a multi-factor authentication because if someone finds out, usually if someone finds out one password, they can find out another. Second thing that I tell a lot of people, don't use as your second authentication for anything that you find important. If I have I don't know, if I have an account that I don't care about because I've rapidly created it, I won't set up, something secure. But don't use your phone number for as a second factor, because phone numbers can be spoofed and reused really, really easily. It's if you're interested in it, you can look online, but it's practically terrifying. Like how easily can someone access either change your phone number or get a message instead of you. So even if they don't do anything wrong with your number, so that's something to generally try using something else. There are authenticator apps online or on your phone that you can use instead of using your phone number. It's a serious security issue. A lot of companies don't allow you to use it if they require multi-factor authentication for login to their servers or access if you're working there. Okay, and this is something that's also really important and something that I hear. It's like, what is end-to-end security? Some applications like WhatsApp will tell you like, oh no, back in the day at least, text messaging, I think WhatsApp actually corrected this and they are end-to-end now. But for example, they would send plain text. So if I write a message, as I wrote, I sent a link here, they will send that exact text to their server, encrypt it, and then send it to another server, decrypt it, and then send it in plain text to the person you are sending the message to. That's not proper encryption, because someone can intercept that message before it gets to the server, and they probably will if they are attempting to cause any harm. So end-to-end means that as soon as I hit send, the actual text or data that I'm sending is getting encrypted locally on my device and being sent to server in the encrypted form. So if someone is connected to my Wi-Fi and is listening to the packets and sees me sending a lot of packets that indicates I'm sending a file to someone, that the data is encrypted and they can't open it and read it. So that's something that is, again, like we check for weight transfer if you're sending some sensitive data. And this is something that's close to my heart. A lot of people say to me, like, "Oh, I don't need to worry. I am clean. I don't do anything illegal." It's not about doing anything illegal. It's about you sending the data that can be used to impersonate you, the data that can be used to access things that you care about, keeping private for other reasons. If I steal your ID and I steal this and steal this, if some social engineering and some conversation and outright begging on the phone number, maybe I can impersonate you to the bank, say something like, "Oh my God, I lost my card. I need another card. Here's my ID. Here's something because you sent your ID to a friend to for an application or something, right?" So be careful about sending your data and be careful about using proper encryption if you are sending it. Okay, so that's all about data transfer. We are going to move into something that's called databases now. So there are essentially three topics left here. First topic that we're going to discuss now is the databases. Then we're going to talk about unstructured data. We're going to mention what's the difference between structured and unstructured. And then we're going to talk about some services, cloud services that exist. So let's start with databases. I won't go very into depth, but I want you to learn, essentially coming from here, what databases are when we're talking about database in a computer science or computer engineering. So here's, immediately the first sentence is a database is structured, and that structured is very important collection of data stored for easy access and management. So you need to fulfill a couple of basic points, and that first it's structured. This usually means a table of some sorts, or a collection of connected tables. And these databases will allow us to retrieve, modify, and organize data. Not every application, okay, I'm be a bit over dramatic, but vast amount of serious applications use databases somewhere in the background. All the websites practically that you're accessing are probably using some sort of a database. If you have a login on that website, it's definitely using a database. Any larger application, even if you think that it has nothing to do with data, if you're using something like SolidWorks or Microsoft Office or something, it has a database in the background. So yeah, they're very, very integral to the function. That's why function of computers today, or the software that you're using, and that's why we're including them in this class. So their goal is, to ensure that data integrity, as I mentioned, security and accessibility. And we're going to look at from, again, an abstract point of view. This isn't in that people who will necessarily be computer science graduates. I know that some of you are in computer science or informatics or computer engineering, but you can consider this as an intro if you have listened to the databases already, or just like a reminder for data, just what databases are, how they work. Okay, so usually if person tells you that this is a database or we have a database or something like that, they mean a relational database. What is a relational database? A relational database means that you have tables that are connected in some way. So we have a student table of students that have information about students. So your first name, your last name, and your first name, last name, your student ID, which class you're taking. and then you will have a table professors that includes all the information about professors, and those tables will be connected in some way, maybe through a separate table or through some sort of a key or something that will basically start to enable to connect us. So I may be able from the database of students find out, hey, which professor's classes is this student listening to, or okay, for this professor, which students had contact with him in each classes, so which students wrote a thesis under him, etc. So that's what most people mean when they say database. If they don't specify, they usually mean relational database because they are very, very common. NoSQL databases are used for, we are going to mention them, but they are used for data that you can't necessarily or don't want to structure in such a way that you have a table of data where every student has every piece of information about them, etc. Something like they're great for stuff that isn't standard. For example, you can, with relational databases, run into problems when something happens that wasn't expected. For example, I used, let's say I have three tables that are classes at the university, then I have professors, then I have students, and I have connections between them that tell me which professor teaches which class and which student, attends which classes. And then a student decides to use something that's I actually wanted to take a separate class at this neighboring university because my government allows me to do that through this program, and now suddenly you can't input the information because that class has different information and structure and everything, so it can cause problems, a lot of problems. For just accessible support, and at the point that you may actually need to call the people who developed the software initially and ask them to modify it. NoSQL databases avoid this, but they are more prone. They are more complicated because not everything is nice and neat, and you need to run additional checks to make sure everything is fine. Finally, object-oriented databases are usually focused around objects in terms of object-oriented programming, where you usually have an element. You have an object is usually so if you don't know object-oriented programming, if you have something, the objects are elements of a class. So for example, if you have animal, right, the individual objects under animal could be something like a dog, a cat, and you will have information that is related to them. You can have something about cars. So car is the class, and then under you will have, like, I don't know, I drive Skoda Rapid. My boss drives BMW Z4, and you will have information for these individual objects. For example, what I have 150 horsepower. I have I don't know, this type of engine. I use petrol or diesel. So they're great when you want to store a lot of information for a similar type of a object, for a similar type of thing. So for example, videos are an example that something like YouTube might use an object-oriented database because their objects are videos, and they will have an entry for each video with the same metadata. Is it how long it is? Where is the, like, a link on the file system to the video? How long is the video? Who posted the video? Is it publicly accessible? Is it meant for children or not, etc. And finally, in-memory databases are, databases that are stored in RAM. Keep in mind, these are volatile databases, so they're usually something that's created, at the moment, you turn on your software. I think SolidWorks does this, and it creates a database for all the elements that you're going to use in the software. And once you are done, you save it. It basically, that database disappears. If you save it, if you say the project is going to save it somewhere on the disk, but by default, it just there are databases that are created as they are needed. So let's talk about basic concepts in database. Again, I'm talking about relational databases. So tables, essentially, what a table is. Just think of it as you have rows, you have columns. So for example, you will have something like if you think of Excel, you open something like this, and you have Excel. That's where you will essentially have information about students, variables that you have, and individual records about each student in rows. Usually, something that's included here is each of those elements needs to be uniquely identified. So this is, for example, why I don't know for each of your universities, but I know I will talk about University of Rijeka or just Croatia in general. Each of us get, your name is necessarily unique. There could be another Sandy Baris Shegota that's enrolled here. So I need to be given a unique key. That unique key for us is our unique jedinstveni matični broj akademskog građana, unique number of unique identifying number of an academic citizen that is essentially used in the entire, under the ministry that governs universities here. It's used as a unique identifier for me. In addition to that, for example, I also have because, for example, the number of publications and research projects is important for us for our government, so they can know how much money they can assign to different universities and different scientists. Every scientist in Croatia, anyone who works at university in a science role gets a unique science number, unique scientist number that you can be used to identify. Primary keys are usually numbers. That's what I'm saying. And you can usually have a secondary key. For example, you can have an email that is also unique and that can be used, as a fallback information as long as it's unique. So it's meant to be, it's important to have a unique identifier in a database. Indexes are just, basically a lookup table that tells you like, hey, this is how this is structured. This is where you can find individual students, etc. And schemas basically define how the tables are connected. So, for example, I have a table of professors and a table of students. I may not be able to directly connect them. Or, for example, classes. I can't directly connect. In this class, currently there are 46 of you here. So I can't create a connection between a class data storage management to one individual person. I'm connecting it to 46 different people out of 100 that are enrolled into the class. So I need to define that somehow to not cause problems, and this is what's defined with a schema that tells me like how am I going to essentially connect these two different entries. As I said, the databases store data in structured tables, so we know how they're organized and how they are related to each other. So I will, through schema, define and say like, okay, one professor can have multiple classes, a class can have multiple students, and students can be enrolled into multiple classes. That's what we are saying. And then through combination of keys, we can actually break down and add additional connecting tables. That will basically be like, hey, this unique key that identifies data storage is going to be that. And when I say key, I usually mean number, but it can be just the name of the class, data storage and management. And this is the table, separate table of all students that are enrolled with it. So I will have essentially, a 3-point level. I have a table defining all classes, I will have a table defining all students and all the student information. And then in between, I'm going to have a table that's called enrolled into data storage and management. That's going to hold all the keys, not all the information, just the keys for all of you who are enrolled here. So, for example, a unique key like your email. And then if I using that, I can go like, okay, I want to find out who all the students are that are enrolled. I want their names. I'm not going to directly access that table with the names. I'm going to I go to my class. I'm going to jump, connect to this list of keys, and then based on that list of keys, I'm going to get your names or your emails or whatever information that I want about you that is stored in the database. This process of accessing data through this is called queries. And SQL is something that SQL, it can be pronounced, I've seen it pronounced a lot of different ways. I've seen it pronounced as SQL, school, etc. I usually pronounce it SQL, but if you hear someone talking about SQL, squirrel, they mean SQL. And that's standard query language. It's not a programming language. It's a query language. It's not Turing complete. This means that it can't actually, do everything related to that you expect from programming. And it's used to, basically modify and access and control databases. Okay, what are some other features of relational databases before we talk about SQL more? We're talking about ACID. So ACID is basically covers 4 elements. That's atomicity, consistency, isolation, and durability. I think I talk about them more. Yeah. Data integrity is, I talk about integrity a lot of time. Normalization, which is created to, minimize redundancy, etc. Is something we're going to mention, and transactions is also something that we are going to mention, but they basically allow you to execute multiple operations at once. We're going to mention why that is important. So let's talk about ACID properties. If you are, in computer science and databases, this was drilled into you, hopefully. Basically, these are the operations that you need to follow to assure that your database is safe, and secure, and it won't fail, it won't cause you problems. So atomicity means that when you're running a transaction, each transaction is atomical, so you can split it. So if I want to enter a new information, I want to enter a new student as Sandy Baresi Segota with an email sandy.segota@uni.hr and etc. etc. I'm not going to do that in 5 steps. All those steps of entering is a single step. So in a single step, in a single operation, I'm going to add a new row, input my name, input any other information, and generate a unique key, and then generate any connecting elements, update any connecting tables that need to exist. Why? Well, let's say I'm doing this separately, and I enter myself into the list of students, but I haven't updated connecting tables. When I try to look up, as I described before, all the people who are enrolled in this class, I won't see myself. I won't get myself back as the result. So I need to make sure, that when I execute a command, everything is completed, and I don't, say it's okay before everything has been completed. If it fails midway, that means I'm going to have to, reset, roll back to a point that I know everything was fine. Consistency means that, basically, if a transaction, if something happens, if I enter information into the database, it needs to follow the rules. It needs to satisfy everything, so I can check everything to make sure it's fine. Isolations means that if I'm running separate information, so basically I don't want to overwrite or I don't want to destroy something that, for example, if I'm adding 2 students in a row, I want to make sure that there won't be any overwriting. And finally, D stands for durability. That guarantees data is saved permanently even after failures. So, for example, if I'm entering myself into the course and it fails for some reason, that data isn't nuked, it isn't deleted out of existence. It might not be stored into the database, but it will be stored somewhere, to the side maybe. Basically, data hasn't been lost even if there was a failure with else. And this is essentially the set rules that you want to follow when you are programming the access systems and enabling people to interact with your database. And the software they will use to interact with your database is basically I hope you can hear me. My microphone disconnected for the moment. So essentially, database management system or DBMS is a software that will allow you to interact with a database. Basically, uh, some will allow you to type in commands and execute them. So we'll have a graphical user interface that allow you to add things. One of my first jobs was actually developing a DBMS for our local shipyard here for their CAD devices. And a lot of people, at least older programmers will have had their start in developing some sort of a DBMS. So, when you're talking about relational databases, that database manager system will implement that database and allow you to perform queries, table joining, printing, describing, and basically any process around the table itself, will around the database itself will be covered by the relational database management system. As I mentioned before, SQL is usually what's used to interact with relational databases. We're going to talk about certain commands and operations that you can achieve with SQL. And this will allow to create, manipulate, query data. When I say query data, I didn't explain before, I mean get data out of the database. And usually not only get data out of the database, but get the data out of the database in a way that's human readable, that doesn't have unnecessary information, etc. Usually different relational database management systems will use SQL in more or less the same way. There are different distributions. MySQL, Oracle SQL, Microsoft SQL, or MS SQL, and so on and so forth. Usually, the base functionality is the same for absolutely everyone, absolutely every single one of these, but there may be some additional functionality that MS SQL will have that MySQL doesn't. But base functionality is going to be, okay and covered with whichever database system you're using. So, some companies may have a preference because this RDBMS offers us this feature that simplifies our development and so on, but basic functionality is available through everything. And basically, what is that basic functionality? It's data definition language, data manipulation language, and data control languages. Basically, data definition is creating files, creating the data entries. Manipulation is modification, and control is just making sure that everything is in the right place. So let's talk about data definition languages. These are some examples, some of these core queries across different RDBMSs based on SQL that are going to be, commands that you can use. So, for example, create will create a new database object, like a table or a new index or a new connection, etc. Alter will modify database objects. So if you want to add rows or add columns or something like that. not rows, if you want to add columns. Drop specifically is very if you have ever worked with databases, when you say drop you get a bit of electricity going down your neck because drop after deletes table, right? And many programmer has found himself or herself in a lot of hot water because they dropped a database they shouldn't have. Modern control languages such as Oracle SQL will usually allow you to have a snapshot that you can go back to or won't completely delete the database object. Still, the classic protection you will usually have the real database, which is usually called production database, and that's the database that you as a user are interacting with when you go on Facebook or Twitter and you log in. You're using a database, and you will usually have a development database. That development database is a copy of the real database that you are uh, working on. So if you accidentally drop a table of all users and no one can log in, no one can do anything at your device, you can just pull back, copy it again and continue working like nothing serious has happened. And that's, one of the good practices when you're working with databases. Another reason why you may want to use, if I mentioned like Twitter or Facebook that had, we're talking about millions, if not billions of users. You don't necessarily want to test your code against something that massive. And considering we're talking about, data science and artificial intelligence in general, you may not want to test your model at, 20,000 data points or 1 million data points. You may test your code against 5 or 10 data points, and if it works for 5 or 10, it will probably work for 10,000. So that's the same basic principle. You can get just a part of a database. Truncate is not much greater than dropping the database. It removes all the information from a table while keeping the table. This is somewhat better because it doesn't necessarily drop can. I mentioned, if you worked, especially if you're a bit older, and you worked with databases before, like secure, backups and stuff like that integrated into RDBMSs. You dropping a wrong table can literally destroy a database. So Truncate doesn't just loses you the data. So it's like shooting yourself in the foot with a 9mm gun instead of a shotgun. You still have a wound, but it's much smaller. When it comes to data manipulation, this is usually what today at least, when companies don't have a single programmer running their DBMS, usually you will have someone who are newer people, recent graduates, and that they will use data manipulation language. I apologize. Just sorry. So as you saw, like data definition language can allow you to cause a lot of damage. So rookies, junior programmers will usually be given tasks that involve mostly data manipulation languages because they can, which basically has less cause to cause damage because you can retrieve, select, insert new information, modify it with insert or update, and you can delete stuff from a database. Difference between drop and the delete is the difference between you spilling coffee in your car or dropping a building on your car. So usually, all databases will have mechanisms that allow you to, get back deleted information, and you need to screw up really badly to like essentially truncate a table by deleting all the rows or something like that. It can happen, but again, usually you can do much less damage with this, and there are usually user level controls that will allow you, like I talked about, file systems where some users can read, some users can just write, some users can execute. Same happens for databases where you might get given permission to just select, like that, just reading, to write, that's inserting and updating, and executing. You can execute a database, but you can delete elements in the database. So this is usually this SIDU, that was something called SIDU, are usually what you as a user are going to be capable of doing at some point, not directly to SQL, but maybe through some user interface. You'll be able to add something to a database or read something from a database. And finally, when we are talking about that controls, you have data control languages, which will tell you who can, either you as a user or a user in the sense of a programmer that is working on a database, what database object they can or can't access and in which way. The option that is revoking, committing. Usually, as I said, you usually have a backup. So if you mess something up, if you today, in modern BMSs, database DBMSs, you will be able to, oh, I dropped the table, I won't commit, I will roll back. I won't commit, I realized I accidentally dropped something I shouldn't have, or I realized I deleted or updated something that I shouldn't have, inserted some information that I didn't need. Okay, I won't finalize this. So your database management system will show you, hey, these are the changes. Do you want to confirm it? And if you click confirm, you're going to commit that, and that finalizes the transaction and damages everything if you mess something up. Rollback allows you to basically go back. Even if you commit something, this depends on the BMS. You may be able to roll back a commit or roll back just information within a commit. So you can, that's a difference, that you can actually use rollback to go back, if you mess something up, and that's a very, very useful function. Again, in older DBMSs, that wasn't necessarily an option. Okay, so let's talk about these constraints and essentially making, some certain operations within SQL that you need. So I talked about keys, that basically unique keys, like your primary key is like your identification number or your email or something like that, that basically ensures that each record is unique no matter what. So even if I have, and this happened to me, I know another Sandy Shigota, who is born on the same day as I am. We met because someone didn't design a database properly. So we had some issues, not on a private level, but, governmental level. So essentially, I was in the table that said Sandy, last name Shigota, born this day, and primary key was a combination of everything. That's not good. Don't do that. Don't create your primary key as a combination of, first name, last name. That's not good. Generate it. There are mathematical techniques and algorithms. One of them is called UUID, unique identifying descriptor. Any programming language supports it, and you can get a string that's guaranteed to be unique through the universe and everything since the beginning of the universe to today. No one has the same, not just probabilistically guaranteed as in, oh, there's a really, really low probability. It's actually through some very clever mathematics, it guarantees that it's completely unique. So use that. Don't be creative with fun combinations of first and last names, because you're going to run into problems. I mentioned that I am a member of that I work with Meteor Astronomy. The old system that they had for submitting observations, visual observations, did this. The unique key was the first three letters of your first name and the three letters of your last name or something like that. So mine was Sanseg. And when another Sandisha got signed up, that would cause a complete breakdown, right? So generate the primary key using some clever mathematics. Don't mathematics are smarter than you in almost all cases. So no matter how smart you are. Foreign key is basically something that's used between tables. So for example, in a table of citizens of Croatia, my key is my personal identifying number that we have here. You probably have something similar in your country. But in the table of students, as I said, we have that unique academical number. So that if you are creating a table that combines, you want to see which Croatian citizens are enrolled into academia in some form, that academic number becomes a foreign key. It's something that's a primary key somewhere else and used as a key somewhere. So it's also unique as well. Then you have uniqueness constraint, so no duplicate values in a column, right? And finally, check constraint. So this means in a column, not a row. So again, these constraints primary key guarantees that each row is unique. This means that all columns are unique. But it means I'm not repeating data. So I won't have mail and email address, right? It's just one piece of information. I won't have last name and family name that all have the same information, right? I know that in some countries it might be last name and family name are different, but in Croatia it's the same thing, for example. So I'm just using that as example. But I won't have the same information entered into multiple columns. And finally, we have a check constraint that essentially guarantees that certain values are within limits. Be smart if you are ever dealing with this, especially as a not a programmer. You might be invited into a meeting somewhere. You're working at a company, you have a certificate that you finished our program, and they tell you you will sit in the meeting, and one of the jobs that's great for you because you have a certain domain knowledge, maybe as an economist, you're going to help us define what are the limit values. Be smart about this. Because you will have problems, and I've seen problems, stuff like, age, we'll define age between 1 and 99, and then someone who is 100 years old can't log into your application. And those examples can be exacerbated, even more. So if you're in a medical field or in economics or something like that, be careful about these limits if you're ever, asked to join in and develop an application or given this is very, very important because I guarantee you, me as a programmer, if I receive a list of limits, I've done this in the past. I was developing a simulation software and it stored information into database, and I asked people who I was working with to basically give me, hey, for this variable, what are the possible limits? And they gave me the limits, and I just copy pasted them. And when I delivered them the software, they were angry. Oh, this doesn't work. I was like, what do you mean it doesn't work? Well, the speed of the car can be higher than 100 kilometers per hour. I was like, well, yes, in the information that you gave me, I limited it. Well, you know that you can that the cars can go faster, in a simulation. I was like, no, I don't. That's your job, not me as a programmer to think about it and possibly make a mistake because I decided to be smart and be like, oh, cars can go faster. People can be older. Maybe, there is a reason for that, and the programmer won't double check with you. Very probably they will just enter the values that you gave them. So please be careful if someone asks you to define limits. Okay, so let's talk about joins. Here's the text, basically what the joins are when you have information in different tables. As I said, I have information on which students are enrolled into which class. Great. How do I show that together? How do I express all the tables, a table that contains all the classes and all the students, or all the professors and all the classes, so I can see if I have a separate table of professors and a separate table of classes, and now I want to see which professor is holding which class. How do I combine those tables together? We have joins. So these joins are basically, this is familiar to you if you ever done some math that involves sets. Left or right join will basically include everything that's included in left table only, right? And right table. It will include stuff that's overlapped, but won't include stuff that's in left or right table in a different table. So if there is, if I'm returning professors here, this is a great way for, if this is professors, this is classes. By doing a left table, I will eliminate all the professors who don't have classes, because I'm not including any information that's from here, right? And vice versa for the right join. Inner join will only return information that's present in both tables that overlaps, and full join returns me everything possible. Yeah. Okay, so those are basically the joins. You just this is useful information to have if you're in CAD, because or you're working with sets, just what union or etc. are, because you may encounter these symbols somewhere whenever you're working with tables. I think even Excel or something, you can create these types of joins. Okay, so this is a bit more computer science heavy topic, which has database normalization, but basically sometimes you will hear a term, oh, it's normalized to a certain form. I will just go through this quickly again. This isn't aimed at computer science for you to make you into a database expert and a computer scientist, but I would just want to cover, because it's very important, and you might encounter it somewhere, if you're getting data from somewhere, and I'm going to try to explain how it relates to you. So basically, we have three normal forms. First, removes duplicates. Second, removes partial. And third, removes transitive dependencies. First is very simple. Okay, there are no duplicate columns, as I described before. There are no columns containing the same information. What are partial or transitive dependencies? Where, okay, when a non-prime attribute is dependent on a part of composite, it doesn't. Yeah. Basically, if you have a composite key AB, and C depends only on A. So what is a composite key? Well, sometimes you can create a unique identifier and add it. Sometimes that's not what you want. You can say, okay, I know this is a bad example. This is not something I would recommend in practice, but it's easier. I know that there are people, like even if I go right now to participate in this class, I can probably find people who have the same first name. So let's say that's A. In B, it's B is last name. But looking at this class, well, probably no one has the same first name and last name. So instead of creating a unique key to save space, because I have a lot of users, I have millions upon millions, hundreds of millions of users, and adding a unique key is going to lose me a lot of data. It's going to take a lot of data to store those unique keys. I'm just going to create a composite key of A and B, right? But if C is a piece of information, that relies only on my first name, right? Like maybe I'm storing in C some information that's related just to my first name or just to my last name. That's called a partial dependency, and that's not a good key because this can cause issues where I can have duplicates here if I ever need to break this key down. Then a transitive dependency is essentially if I have something that depends. So again, this is the definition occurs when a non-prime attribute depends on another non-prime attribute, and evaluates the third normal form. So basically, you need to satisfy, no duplicates means you're satisfying the first normal form, no partial dependencies when you satisfy the second, and if you want to satisfy the third, basically means that you won't have. This is easier to understand. If A depends on B and B depends on C, then A depends on C. This means that you have information in your table that is not necessary, because you don't need to describe this when this already describes it. There are mathematical processes that you, obviously, first normal form, right? You just check whether you have duplicate columns. But there are mathematical processes dealing with sets that you go through for second and third normal form to guarantee you don't have these types of dependencies. I think they're beyond the scope of this class, so I won't go into them because, to quote Stephen Hawking, for each equation you put on the screen, you lose 50% of the people. So I won't enter into here. If someone is really, really interested in this, and these on the computer, if you're a computer scientist, you have learned this or will learn it. If someone is really interested into this, email me and I will give you some, materials or link you to places where you can learn more about it. But I won't go into details. Okay, again, primary key and foreign key. Primary key is unique identifier in the table. Again, as I mentioned, it can be uniquely generated. It can be, as I said, composite. Foreign key, references a primary key in another table, so we can establish relationships. Like I said, it's actually a key from a different table that you have joined to this table, so I can look up information. So let me repeat again. My primary key as a citizen of Croatia is my personification number, but to that I can add my student identification number, and that student identification number can be used. So, for example, if I'm accessing my table of citizens in Croatia and I look up Sandi Baresi Šegota and I want to look up information about Sandi Baresi Šegota as a student, which classes I have passed, which I haven't, which level of study I'm enrolled in, etc., I'm going to use this foreign key that I have added. So it's essentially just a primary key from a different table. And that's, it's basically, it establishes relationships in relational databases, because I can use this foreign key to look up information about other elements, other tables about me. Again, I mentioned indexes before. Basically, an index allows you to, the simplest form of an index is just a number of the row, right? So if you create a column that says like this is 1, 2, 3, 4, 5, 6, 7, 8, it enables you to reach it much faster. If I know that, this is a 10th student in this class, let me access it, etc. You have probably, if you work with pandas, you can see that pandas automatically generates an index, which is, as it describes, simply a number from 1 to 10. There can be, again, there are mathematical processes, I believe they are outside of scope of this class, that enable you to create well-functioning indexes that are unique and help you easily reference individual parts and help you search up. For example, one type of index that you can have is just simply indicating whether a certain, for example, if someone is older than 65 and is currently unemployed, they are probably pensioner, right? So I can create an index that automatically checks. This is a very simplified thing, but checks these two elements. Is basically writes whether the person is a pensioner or not. So now I can, if I want to get a list of all retired people, I don't have to check their age and employment status individually. I can just look everything up based on that index that I've created. So that's an example of an index. Okay, so what are views? Views are also something that's very useful, and essentially it's a virtual table. And this is used for end users. So if I'm creating, something in SQL, I won't necessarily want to give everything to you. So I may, using the joins, create a separate table that I'm exposing to you that you can use in a much simpler way, because you don't have the whole all the relations, the entire schema created in front of you, and it's very complex. You maybe you don't need to understand the whole schema. I'm essentially giving you a much simplified view into the database. Another element of where this is important is security, because you don't need to know all the information. Me as teaching staff here at university don't need to know all the information about the students. So they want, if they are giving access to the database, for some reason they will probably give me a view that limits some personal information about students. You know, I don't need to know the student's address, but the university, the faculty might need to know it so they can reach them, etc. So that's an enhancement of security, and and it allows abstraction and usability of common queries. So if I'm because I can rename and refit tables. So for example, I can say something like, okay, I already have a big query that deals with student, first name, last name, so I'm going to create a view that fits this query instead of adjusting the query. Yeah. Okay, so I mentioned, transactions, but it might not have been clear what is the difference between a query or a transaction. Basically, a transaction is a group of multiple queries, and as I said, transactions need to be atomic. So if I have one query that updates students, and another query that updates, as I said, let's say we're having an example of this is, a national database of every person in Croatia, and I'm becoming a student now. So I'm going to need to, the first step is add a new row to the table of all students in Croatia and generate, the academic identifier number. And the second step is adding that identifying number as a foreign key to the first table. These are two separate queries. One is the create query, one is the update query. Because first creates information in a table, the other adds information about the table. You don't want to run just one, because if you look up at students, you won't see me, because you don't have that foreign key inserted, and I can basically disappear into the database when someone tries to reach me, etc. So that's obviously not good. So transactions are basically groups of statements, and they will check basically that all of the changes that I want to do to queries happen, or none of them happen. Right. So if there is an error in my example, if I create a student, but I can for some reason enter a foreign key, maybe because I have been given a view of the database that doesn't allow me to access the table of all citizens in Croatia, that means that this transaction won't happen. And usually the user will get some sort of an error or a warning or something telling them, hey, no information was changed. This is the information that you wanted to enter. This is why we couldn't enter the information. And they can then adjust the query or seek permissions or anything to enable that to happen properly. So that's very, very important that this second point, that transactions ensure that all the changes that need to happen either happen completely or not at all. Okay, that's very, very important because you will very rarely have a single query when you're running any sort of updates, because at the very least, if you're modifying, if you're adding something, you need to add all the foreign keys into separate tables. Okay, what are procedures? Procedures are precompiled SQL code that can be used across applications. Essentially, they're queries that you write in advance, and each query essentially has it's a piece of code that you can go. So let's say one of simple query would be, I'm going to type it in the chat, select star from students. And this basically means, so select star from students, select is the order, star means everything. It's shorthand generally in computer science. The star is shorthand for everything. From tells you which table, and the students is the name of the table. So if I run, so that's something that I run often. I often need to get all students. Something that I mean that I may need to do. Okay, something that I may need to do often could be accepting from a certain year, students from a certain year. So something like this that I wrote. So we have the same as before, select star from students. So select all entries students, and then I have where, which is essentially if. If you're familiar with programming, as you should be because you listened to a class before, where year equals 1. So I will select all the students from the first year. I don't want to write this query every time, and my end users don't need to write this query, so I may just create a procedure that's called students1. And that students1, when I type it in, is going to run the query from above. Why is this beneficial? Well, first of all, it's faster. Second of all, it's faster to type students1 than select star from because queries can get extremely long. The second is that my end user doesn't need to know as much SQL as me, because they are not end user, I apologize, my junior programmer doesn't need to know as much SQL as me, and doesn't need to be as familiar with the database, because if he needs, if this query is much more complex, he can just type in students1 and get it. He doesn't need to, not know to actually write complex SQL queries on this complex schema that I have. But the third example is safety, and safety is basically SQL injection. Injection is you basically entering code that executes a query. So let's say let's say I want to run something like select star from students, where let me actually use a notepad to show you. Okay, my notepad is taking some time to start up for some reason. It might be a time for a new computer. Okay, so where I'm doing something like this, where name equals Sandy. Okay, very nice, very simple. In reality, something like this means that you will have a box on the web where you type in Sandy, and you type in, you have something like student name, and you type in my name, and this returns all students who are called whose first name is Sandy. Okay, great. What happens if you in that box type in drop table students? Now your query doesn't look like this anymore. Your query looks like this. you have this drop table students entered inside, and essentially, depending on your database management system, modern database management systems are secure about this. But depending on if you have an older one, it could execute this first. And if you haven't done your security setup properly, and you are enabling this user who should only be able to read, you are enabling them to drop and delete stuff, they can mess up your database really, really badly. Remember when I said that database is usually, drop is very bad. This is an example. It's an old comic for a couple of decades old at this point. Uh, basically says I named Robert drop table students. This is my son's name, and what happened is that they lost their student records. This is a common joke because SQL injection was a serious problem a couple of 20 or so years back, and you can still occasionally, older database engineers will sometimes as a joke try entering something like this. And yes, I have heard of cases where people, again, I won't name anyone, but I heard like big companies and big agencies in like last couple of years who have had their databases damaged because someone, as a joke, tried doing SQL injection on them. So that's something that you want to avoid by using essentially predefined procedures and using views and using safety to control who can and who can't do different things in your table. Another thing that you want to set up is triggers. So triggers, are automatic access, automatic operations that happen when you do something. One of the examples for doing this is, whenever I insert something, when a transaction that contains insert or update happens, check that all the foreign key is entered into all the databases. Use select to print out and assure. If I'm using delete, if I'm deleting the user, make sure that user's foreign key is deleted from other tables. That's something that is quite common, quite useful to set up to make sure the consistency, in databases stays there and you aren't either forgetting to add a certain piece of information or forgetting to remove information that should be removed because you can run into problems by not removing data. Okay. And finally, you have just to mention database backup recovery. Most DBMSs will have ways to store full databases and basically, dump an entire database somewhere outside, and you will be able to set up that to do that automatically. And yeah, as I already talked about redundancy and why keeping extra data is important. Again, security isn't much different in databases than talking about general data security. You can use access control, as I mentioned, authentication to make sure only people who are accessing it are people who you want to know, and authentication, I would add authorization here, to control the access those people have once you verify who they are, and obviously encryption in case someone uses SQL injection, as I mentioned before, uses it to get all the information out. As I use there, I use something like drop table students, but I could have simply used something like select all from student banking info. where you have a student credit info. For example, if you have, maybe you're capable of paying with credit card for your, yearly fees or something like that. We can do it here. I don't think they keep the credit card on file, but if they do, and I can get all of that information. That's the sort of information that should be encrypted, right? It should be encrypted with some key that I have stored somewhere, and if you need to know both pieces of information to get it, and not only know the key, but you need to access it. You need to know the key, and you need to know the algorithm that I'm using to unlock it. So yeah, so you should use some sort of encryption, and again limit access based on user roles. If you are allowing, that's usually something that's lazy. But in this same example that I used just now, why is someone who can search students by name, why are they even allowed to, do they need to be allowed to access their payment information? Usually not. So that's something that you need to take care. And there are actually, in companies that have large databases and that are dealing with them, there are usually people who are in charge of just making sure, that these views and user roles and permissions are in order. Okay, and another thing, this is something that if you are, entered the social aspects of AI, we're going to talk a lot. It's compliance with data protection regulations. You can secure it through triggers and whatever, but again, that's something that is a whole separate topic. Okay, so I mentioned NoSQL databases before. Uh, Again, NoSQL databases are flexible, are much more flexible. If you have a large volumes of data that are unstructured, you need to store them. High velocity here means just data is being entered rapidly. As I mentioned, YouTube uploading videos, millions of videos, tens of millions of videos a day. Yeah, you need to enter this quickly. Relational databases, it says here, provide strict schema enforcement and ACID compliance. Non-relational databases, like NoSQL, don't. So yeah, that's there are it's making a sacrifice. So for example, it won't guarantee the atomicity, it won't guarantee on everything, but sometimes you don't need it. Like we talked before about TCP versus UDP. UDP as a protocol is, you could say, oh, this protocol is really bad. You don't check anything, you just send the data. But sometimes that's what you need. You don't need so many checks, you don't need to verify so many things. You need to just run put the information, store it. On a YouTube video, if you make a mistake and mistitle it or something, who cares? It's not that big of a deal. It's not world ending. It's not. I mean, it might be a big of a deal, to the person who uploaded the video or something, but it's not as big of a deal as making sure that this person gets the right medicine. I'm talking it in that order. So when we talk about NoSQL databases, there are different. NoSQL is a whole group of possible databases. So I'm going to just quickly mention them. Key value stores basically store data as key value pairs. Key value is basically something like if you want to store phone numbers, that's something that's used. So your key is the name of person because that's something you can quickly recognize, and the value is the phone number. So that's an example of key value store, key value database. And database is something, there's for computer science, you probably have heard a joke, oh my God, they're using Excel as a database. Excel can be a NoSQL database. A CSV file can be a NoSQL database. Of course, you will still prefer to use something like Redis, DynamoDB, or some, a dedicated piece of software for this that will allow you some deeper checks and some deeper security, etc. But yeah, so that's a very simple example of a database where you have, a unique key that can be, someone's name, and then a phone number, for example, or an email address or something. Document stores essentially convert data to JSON. JSON is essentially for people who don't know it. Let me just find an example. It's something like this. So you have, information, first name, last name, some parameters, age, address. You can have this like sub information for address. So you have street address, city, state, postal code. Essentially, this is something that can be used. You can create a database based on a bunch of files like this. So for each person, you have a separate JSON, which is a separate file, and you use that as a database. One example that we are currently developing is a database of industrial robotic models that use basically a JSON-like file format that we have developed that exist basically for researchers around the world who deal with industrial robots who want to download something or get information. Basically, it stores information for them. So that's an example of something that I'm currently working on with some colleagues. Column family stores are a bit more defined. Basically, they are tables with columns that can vary. It's okay. It sounds a bit stupid, but what do I mean by columns that can vary? Column, if I say column, data, right? I have event ID or something, and then I have data. Data can be different. So I'm going to have different columns for different types of data. So I'm going to have, in case that the data is text, in case that data is image, in case that, and I have a column family of data for different types of data. That's an example. And finally, graph databases. When I say graph, I mean just general in computing. When you say graph, you don't mean this type of graph. We mean you probably talk about breadth first search or something like that in introduction to AI. This is graph in computing, in computer science, right? It's just a series of nodes connected in some way. One useful thing, for example, is using a tree. Tree is simply a special case of graph that has something like this. It starts one and then it branches as you go lower. So that's like a special case, and so that's something you can represent. You can represent information about families. It's very commonly used, for example, for animals, tracking animals in the wild and their children. So yeah, those are graph databases that can be used for when you already have graph data, and each of these circles that are called nodes will contain some information, and it will be connected to another node in some way. So, for example, this is very practical. If I'm talking about, this is some person and they have connections to different people, and I want to figure out how I can reach, how I can get contact of number 7 if I'm person 1. I can have a database that's stored that defines these particular connections. So what are the basic advantages of SQL? You have, as I mentioned, high scalability and performance of distributed systems, because no matter what you're using, because it's not as strict as SQL is, so you can more easily scale it. You can more easily improve its performance and adjust it, because you can decide to ignore certain elements that are guaranteed in SQL. again, very similar in concept to UDP versus TCP. Again, and depending on the form, it can be specified for specific, especially like an example is these graph networks. If you're trying to represent something that's already a graph, it could be a problem with tables. If you have one way to represent a graph with a table is to have a column for each, a column and row for each of the nodes in the graph, and then you can write whether they're connected or not with 0 or 1. That's a lot of data. That's a very, very big table. It increases with n squared. So if you have 100 elements in graph, you're going to have 10,000 data entries to describe that graph in a table. While if you have a graph by itself, you have with 100 entries, you have 100 entries. So yeah, you can. It simplifies your life significantly. Okay, these are some use cases. I already went over some of them. Real-time analytics, recommendation engines. Recommendation engines are something that you saw if you're ever shopping online, and it tells you like, hey, this is the drive that you should buy, or other people that bought this also bought this. That's something that is based on NoSQL. And if you talked about it, I assume you did clustering. If you talk in introduction to AI or something, clustering techniques are used. This with NoSQL databases to figure that out. Like people who bought this also like this, etc. Social media platforms, of course, because it's nice to representing engagements with a graph. It's much simpler than looking up tables. And again, IoT, big data applications requiring, as I mentioned, fast scalable storage, because tables aren't necessarily scalable, as I talked about. Okay, so let me just conclude, and then we'll be done for today. Databases are essential for structured data storage and management. If you want to guarantee that something that's structured, something that's safe, something that's stored, you're going to use an SQL database or something similar, very probably an SQL database. What I wanted to do with this, is just show you some database fundamentals, because I want you to, basically, I want you to keep this in mind, because if you're ever involved in a project or something that's developing something, right? It's probably going to involve some sort of a database. They're pretty ubiquitous, especially at lower scale. So we're going to talk about unstructured data more later on. But I want you to just have the basic understanding of what people mean when they're talking about database, and why isn't it a simple Excel file or something like that. So that's something that I wanted to show you for those people who are in informatics, computer science. I know I simplified some things and some explanations, but I wanted to keep it simple in some cases. Okay, so essentially that is it for today. If you have any questions, you can ask me now, send it to my email, or write in chat, whatever. I'm going to stay here for a few minutes after I finish. Next time we're going to cover, we talked about mostly structured data. We're going to talk about some specific not NoSQL, but some other techniques that can be used to get data that is completely unstructured. So that's something that I just want to clarify. NoSQL isn't unstructured data. NoSQL is less structured data. So you will still have, I'm using, because I have fairly nicely open this graph with, this graph example. This is definitely structured. There are connections, there are places. Yeah, but we're going to see what to do when data is almost completely unstructured. We're going to talk about that a bit. So yeah, that's pretty much it from me. If you have any questions, feel free to ask.
I have a question. I don't know if it's relevant or not. When we create a database, can we use connections or links between open source databases that are already exist with the one we create alone?
Okay. So that essentially depends on the open database. Basically, some databases out there that are public accessible or partially public accessible will have something that's called an API, and it will tell you like, hey, you can create an account and you can query this database. Sometimes you can query it directly, and you can create a connection virtually, essentially by sending, okay, when a query involves this external database, I'm going to query it outside of my system that I have installed. Or you can just create a copy of a database and drag it down to your system and use it like that. It really depends on what the open source database gives you, what the people who curate it enable you and tell you whether you can and decide whether you can use it or not. Usually you will be fairly limited in what you can do on open databases, so you won't be able to drop tables or create new tables or anything. You will be limited to that, select, update, insert, and delete. Yeah.
Okay, thank you.
Okay, anyone else? Okay, if not, thank you very much for your attention today. I will see you, I think, tomorrow. I think tomorrow is. I see someone has raised their hand, so.
It's just a question about the Erasmus project. I just wanted to ask. I'm a student at the Ionian University, and I just wanted to clarify something about the verification we'll get after the program is finished. I just wanted to know if there's a specific date where we will get the verification, because I might need to book some tickets for Christmas vacations where I go back to Athens, and I just wanted to know if there's a specific date where we get the verification of us participating. That's all.
It's okay. So I mean, everything will be verified, but so. Are you worried? So I don't understand the question. Let me just check. Are you worried about us checking your attendance, or are you worrying about receiving the certificate? I didn't quite understand.
I'm worried about receiving the certificate, because I'm not sure if for example, if let's say I leave a few days before we get the certificate, if I will be able to get it after I'm back from holidays, for example. And I just wanted to
so this is the process that I will communicate this with you in the email once we have the once we have it officially. But once we are done with all the classes, everyone will get a link with one more form to just fill out. We will essentially check if you have appeared or watched the classes or completed whatever was necessary, and we will send you the certificate digitally. So you will receive it. So essentially, you can, if you have an internet connection, you can do it. But basically, that form will remain open. So if you don't have time, for to submit it, you can submit it. Even a month or two in January once you get back. It's not a problem.
All right, thank you very much. That's all. And thank you for the lecture as well. It was very good, and you've explained everything very nicely.
Thank you. Thank you. Okay, with that is all. You're free to go. If you have any questions, other than that, feel free to email me, ask, and I will see you. Yes, tomorrow at 4 is our last lecture, so I will see you then. Okay, goodbye, everyone.
Thank you. Good night.
Thank you. Good night.
Good night.
Night.